Hello everybody, Mr. Johansson here. Let's talk about sediments and some of their characteristics. So here we're imagining we have jars of sediments that are large, sediments that are small, sediments that are medium, and sediments that are small. These are all rounded sediments. Their only difference is one is large, one is medium, one is small. And then we have one other jar where it's all of them mixed together. Okay, so we want to think about what would the porosity be of these things. So the amusing part is, when I ask, some people vote for more porosity here or more porosity here. The thinking here goes, well, there's fewer pore spaces, but they're all quite large here. There's small pore spaces, but there's so many of them. Okay, well, that all balances out. Porosity is the same for these. It's all the same. You can fit the same amount of water in each. But porosity is less here. Why? Well, think about it. It's sort of like this, but now you filled in all these pore spaces with the various mixed sizes. So there's much less pore spaces when you have it mixed. All right. How about permeability? Well, if we covered these with a grate and poured water onto them and had a grate on the bottom so water could pass through that screen, which one of these could you pour water through the fastest? Most of you would agree that the large particles, because they're huge pore spaces and the stickiness of water really doesn't come into play here, that you could pour a large amount of water through here. So these are, in terms of the permeability, this is very permeable to not very. And the smaller the particles, the less and less permeable it is. We don't have to worry about permeability here. It would be somewhere in the middle. But large permeability when you have large particles, small permeability when you have small particles. And think about places in the ground where after a big rainstorm, the water just sits on the ground for a long time. What kind of sediment is under that, do you suppose? Correct. Clay would be a good answer there. Very small sediments will not allow the water to pass through it easily. Remember, down by the Delaware River, after a rainstorm, there were some flat areas that would hold the water for days. It turned into a small lake. It just wouldn't let the water pass because the river very often will make big clay deposits places. If you think of a sand deposit, that's not going to hold the water. The water will pass through fairly quickly. So permeability, high permeability with big particles, very small permeability with smaller particles. Now there's one other thing, capillarity. Capillarity might not be a familiar word, but it's happening all around us. It is the ability to draw water upward. Imagining standing in a stream. If you have a stream flowing by and you're standing there and here is your leg and you're wearing jeans, here's your shoe there, right? And you have jeans on. The jeans will draw the water up and up and up. And the jeans will get wet far above the surface of the water. Why? They're drawing the water upward. They have a lot of capillarity. Now, if you wrap yourself in a polyester net or something, there's nothing for the water to climb up there, and it would not wrap. It would not be able to go up that netting very far on you. But because the fibers on cotton are so closely spun together, the stickiness of the water will allow it to draw up. So consider capillarity in these situations. So would this allow water to draw up very much? Not at all. So capillarity would be low here. Here is stickiness of water. So capillarity would barely go up here at all. It would go up here more. And here it would go way up. So capillarity works very well with small particles. So large particles, not very much capillarity. Medium seems to always be in the middle. Small has the ability to draw water way up. Now, why is this important? Well, if you have underground, say, a water table, far under the ground, there is a water table, surface of the zone of saturation. Capillarity will draw the water up above that, and if you have a tree and its roots are going down, the roots may get into the zone of capillarity. And the zone of capillarity means that you're in a wet spot where the water can get into the roots and keep the tree alive much longer. Now, if the tree could get all the way down to the water table, even better. But a lot of times that's not possible, but the zone of capillarity is all that it would need. So that's the ideas of porosity, permeability, and capillarity, right? And how it works in sediments. Hope you enjoyed it. Thanks.